Good evening, everyone, or morning, or whatever time of day it is. So today we continue looking at geometric growth and decay, and using a model to show this, and an nth term model to show this. So we're asked or told that a computer system costs $9,500 to buy, and decreases in value with the reducing balance depreciation of 20% each year. Our current relation's given, and that is right there to show the information. Now, it wants us firstly though, it's almost pointless part of the question, so almost ignore that it's there. You know that it's $9,500, you know that it reduces by 20% each year, and the first thing we want to do is to write down a rule for the value of the computer system after n years. Okay, so this is after n years. This could be after 100 years. Okay, computer might be worth nothing, but that's what we want it to. We want to be able to calculate at the end of the day what it's worth after that time frame. Okay, so we're going to remember the rule, or the makeup of the rule. So the rule is Vn is equal to R, just the rate of change, to the power of n, number of periods, and that's all multiplied by the initial value of V0. Okay, so what we want to be able to work out here, or put in place, is we want to know R, and we want to know what V0 is. V0 should be easy for us. So initially the system was worth $9,500. And R, the rate of change, the only thing we need to consider here is that it's 1 minus the percentage change every year. Okay, so 20 over 100. So it's reducing by 20% each year, so that means we have 0.8 left over every year. All right, so that's our R value. So our rule is Vn equals R to the power of n. Sorry, what am I doing there? Start putting in some values. 0.8 to the power of n multiplied by 9,500. Done. Okay. Use the rule to find the value of the computer system after 8 years. So this is why we're using a rule and not the recurrence relation. Don't want to be, it's not too hard once you plug it into a calculator, I guess, but much easier if we can just write in V of 8 is equal to 0.8 to the power of 8. So we're applying that 8 times, multiplied by $9,500. Okay, so once we've put all our known values into the model, we can now jump into our calculator. 0.8 to the power of 8 multiplied by 9500, and we get our value of 5. Calculator's disappeared. $1,593.84 rounded to our 2 decimal places there. Okay, so tick for that. Calculate the total depreciation of the computer after 8 years. So this is just asking you to apply what we already know about it. So part C, we're talking about the total depreciation. It's how much it's lost in value over that 8-year run. So we're thinking about, we've started at a value of $9,500 and it's now dropped to that after 8 years. The key is that that is not the depreciation. The depreciation is $9,500. Take 1,593.84. So our value is 7,906 and 16 cents. And that's the depreciation of the computer. Okay, we'll leave it there, guys. Give it a thumbs up, like, throw a comment in if you want something changed or any recommendations or requests. Cheers, good night.